Google's quantum echo algorithm shows the world's first practical application of quantum computing. Willow 105-qubit chip runs the algorithm 13,000 times faster than a supercomputer. Now you can indeed now know how Schrodinger's cat is doing. As quantum computing doesn't show up often in the news, after all, it has gigantic potential, but the technology has been promising practical, real-world uses just in few years, 4 decades now. The science world may have finally reached a tipping point for practically though. Google's engineers demonstrated a world first of running a verifiable algorithm on its Willow quantum chip at 13,000 times faster than a supercomputer. The algorithm in question is called quantum echo and models of physics experiment in nuclear magnetic resonance NMR, the spectroscopic variant of a popular MRI, revealing internal molecular structures by detecting magnetic spins at the center of atoms. According to the Google, Willow runs this 13,000 times faster than the best classic algorithm on the world's fastest supercomputers, meaning that the one chip is many orders of magnitude faster than an entire data center and this specific task. What's exciting and world first about this experiment is that it's verifiable, meaning that the Willow results are reproducible and were checked against normal algorithms, or in this case by nature itself, since its molecules and atoms are being analyzed. Likewise, the experiment marks what is arguably the first real-world use case for quantum computing. This is a gross oversimplification, but the main issue with quantum computers is that they are not intrinsically deterministic. They arrive at a probable solution, although they have the advantage of considering most of every possible input simultaneously. Hence, the insane speeds up set for highly specific tasks that fit the exact board. So a quantum computer solutions are thus inherently error-prone, and it's necessary to reduce the error rate by several orders of magnitude to make practical application viable. The fact that the quantum echo is de facto verifiable and deterministic comes by the way of sending a ping to Willow 105-qubit array and reading each effect millions of seconds, revealing the information about the state of the system. Thus, again, I'm oversimplifying, letting scientists peer into the outcome without significantly altering it. This is apparently the largest such type of data collection in any quantum computing project and was key to making the NMR analysis verifiable by helping reduce the error rate enough to arrive at a deterministic solution. The team predicts that the quantum computers are key to modeling quantum phenomena in nature, as in the aforementioned example, and it's not hard to imagine other similar applications now that a baseline for practically has been reached. Google Quantum AI is now moving to milestone 3 of its roadmap of building a long-lived logical qubit. Schrödinger would be happy. Next one is the global memory price is set to surge 15 to 55% in Q4 amid tightening supply. The consumers and businesses should brace for a surge in the cost of everything from smartphones to servers as the global memory chip market stages a dramatic rebound. The industry's largest manufacturers are planning significant price hikes for the end. Next one is from Synopsys. Synopsys collaborates with TSMC to enable 2D and 3D design solutions. Collaboration enables workflow for TSMC advances node technology, accelerating AI, high-speed data communication, and advanced computing. Key highlights on AI. Assisted optimization workflow helps shorten design cycle times on TSMC Compact Universal Photonic Engine CUBE platform and strengthens design quality using ANSYS OT-SLang, ANSYS GEMX Optic Studio, and ANSYS Numerical FDDT simulation software. ANSYS FSSS IC Pro platform is certified for system-on-chip electromagnetic extraction with TSMC N5 and M3P process technologies, ANSYS Radio SC, and ANSYS Totem. Power integrity platforms are certified for the latest TSMC N3, N3P, N2P, and A16 process technology releases. Sunnyvale, California, September 24th, 2025. Synopsys Incorporation today announced TSMC has certified the ANSYS portfolio is simulation and analysis solutions, enabling accurate final checks on chip designs targeted for TSMC most advanced manufacturing processes, including TSMC N3C, N3P, N2P, and A16. The company also collaborated on AI-assist design flow for the TSMC CuPath platform. Together, Synopsys and TSMC empower customers to effectively design chips for a range of applications, including AI acceleration, high-speed communication, and advancing computing. Multi-physics and AI-driven photonics design enablement. Synopsys continue to work with TSMC to expand the multi-physics analysis flows for large designs with the hierarchical analysis methodology. The multi-physics flow include ANSYS RedHawk SC and ANSYS RedHawk SC electrothermal platform and Synopsys 3D IC compiler explore to sign a platform to enable hierarchical thermal-aware timing analysis and voltage-aware timing analysis. The multi-physics approach can help customers accelerate the convergence of the large 3D IC designs. ANSYS OT-SLang software and ANSYS GEMX Optic Studio software transform the design of optical coupling systems in TSMC CuPath architecture by applying AI-assisted optimization along with the sensitivity analysis to shorten customers' design cycle times and strengthen the design quality. These tools enable engineers to incorporate custom components such as gradient couplers optimization with photonic inverse design using ANSYS numerical FDTD. So, advanced process technology solidifications. ANSYS Red Hawk SC and ANSYS Totem are foundational solutions for digital analog power integrity that verify the project can function reliably and meet the performance goals. The solutions aid in validating power integrity of chips using TSMC N3C, N3P, and N2P and A16 trademark process technology. Likewise, ANSYS HFSSIC Puro solution for electromagnetic modeling of chips is certified for TSMC's N5 and N3P processes. So in addition, Synopsys is collaborating with TSMC on design flow development for TSMC's A14 process with the first photonic design kit release scheduled for the later part of 2025. And this Pathfinder SC trademark is a newly certified electrostatic discharge current density ESC ESD-CD point-to-point P2P checker for the N2P process, validating chip resilience against electrical overstress surges and instilling confidence in engineering teams. Unique in its capacity to quickly check even the largest chips earlier in the design cycle, this solution accelerates design process and increases product durability. ANSYS Pathfinder SC is enabled to support complex 3D integrated circuit, 3D IC, and multi-die systems. Synopsys is working with TSMC to expand the tool capability for large-scale 3D IC design analysis. ANSYS HFSSIC Pro is certified by TSMC for die-level analysis on its advanced 5nm and 3nm process technologies. The collaboration enables customers to meet the demands of complex applications including AI, HPC, 5G, 6G, communications, and automotive electronics. Synopsys provides a broad range of design solutions to help semiconductor and system designers tackle the most advanced and innovative products for AI enablement, data center, telecommunications, and more, said John Lee, Vice President and General Manager of the Semiconductor, Electronics, and Optics Business Unit at Synopsys. Our strong and continuous partnership with TSMC has been a key factor in maintaining our position at the forefront of technology while providing consistent value to our shared customers. TSMC's advanced process, photonics, and packaging innovations are accelerating the development of high-speed communication interfaces and multi-die chips that are essential for high-performance, energy-efficient AI systems, said Avik Sharkar, Director of the Ecosystem and Alliance Management Division at TSMC. Our collaboration with OIP ecosystem partners such as Synopsys has delivered an advanced thermal, power, and signal integrity analysis flow, along with an AI-driven photonics optimization solution for the next generation of designs. About Synopsys. Synopsys Incorporation, Nasdaq SMPS, is the leader in engineering solutions from silicon to systems, enable customers to rapidly innovate AI-powered product. We deliver industry-leading silicon design and IP simulation and analysis solutions and design services. So we partner closely with our customers across the wide range of industry to maximize their R&D capability and productivity, powering innovation today that ignites the ingenuity of tomorrow. Okay, next one. This is from ANSYS. Synopsys collaborated with TSMC to enable 2D and 3D design solutions. Synopsys collaborated, I think this is almost the same. Oh, same thing. This is another story from the storage newsletters. NAND flash prices to rise 5 to 10% in Q4 25, says TransForce, driven by the spillover demand for the QLC product. The Transport Corporation latest investigation has revealed that while the consumer's demand was concentrated in the first half of the year, leading to traditional second half peak season underperforming. And the market has expected NAND flash had expected NAND flash prices to stabilize in Q4 25. However, the HDD shortage and no longer lead times have prompted CSPs to quickly redirect storage demand toward QLC enterprise SSDs. This urgent surge in orders has resulted in a significant market volatility. SanDisk was the first to announce 10% price increase, while Micron folded quotations due to pricing and capacity issues. This event shifted supply-side sentiment from cautious to aggressive. Consequently, NAND flash contract price across all categories are expected to generalize, and with the advantage increases of 5 to 10% of Q4 25. The trends also highlighted that is supply node production reduction and inventory clearance during the first half of the year have greatly enhanced the market equilibrium, reducing both the prior inventories and pricing the pressures, aside from a few leading companies planning to extend their new fabs next year. Most suppliers are focusing capex on migrating the advanced process to order to improve cost efficiency. Capacity is allocated to high-margin products to minimize the price competition and safeguard profit, creating a price support layer. Regarding the product side, QLC cost benefits has increased its adoption in SSDs. As generative AI drives higher demand for extensive data storage, and suppliers more focuses on expanding the QLC capacity. On the demand side, the NAND flash market continues to encounter weak consumer activity, slower OEM purchasing, and high finished goods inventories in the distribution channels. Nonetheless, the several OEMs and CSPs mostly cleared their inventory in the first half of the year, with NVIDIA's upcoming Blackwell chips expected to increase shipment in the second half of 2025 and the ongoing HDD shortage. Demand for enterprise SSD is growing rapidly, so this situation helps keep the overall NAND flash demand on a positive path. The client SSD. In the first half of 2025, the production cuts and shipment adjusted by the client SSD suppliers have greatly decreased inventories, helping to restore market balance. Meanwhile, the demand for the large capacity QLC SSDs, which are priced for their cost performance benefits, remains high and further supporting the market. Enterprise SSD. SSD suppliers are re-evaluating their 2026 order volumes due to the increasing demand for the enterprise product exceeding 120 terabyte. They are also strategically increasing QLC output shares to adapt to fundamental market changes. Suppliers' inventories have dropped below the healthy levels, and the growing demand for AI and servers in North America, supply shortage in 2026 are becoming increasingly apparent. This situation is likely to drive prices upward in Q4 25. eMMC UFS. Within the NAND flash supply chain's profit-driven strategy, SSD achieves a higher margin, and whereas eMMC and UFS experience weaker demand. International suppliers face stiff competition from YMTC and many Chinese module makers, and increasing bargaining power for local smartphone brands. High inventory level among the module makers could lead to price competition, which might restrict price increases. However, in an effort to recover losses, suppliers are likely to raise eMMC and UFS prices in the fourth quarter of 2025. The NAND flash wafers. During the process migration, suppliers faced temporary output gaps caused by the line adjustment, which reduced bit output. To compensate for losses from earlier quarters, they are relocating the resources to high-margin product lines and leading to the further wafer supply constraint for module houses. As investment in enterprise AI continues to grow, the tight supply conditions are expected to persist, pushing wafer prices higher in Q4 25. So, comments. NAND revenue continues to rise, and at the same time, a small price increase appeared to an SSD as QLC really leads the demand. This is, of course, an effect of QLC demand from hyperscaler and global enterprise in all domains, but AI really ranks number one, meaning that SSD is present in all market segments and verticals. No surprise here. Hyperscalers are looking for the low-cost QLC SSDs as they are consume all their storage devices as just component and commodity. But it appears that HDD vendors struggle with the production. On this SSD demand, large capacity flash drive is showing the strong demand for 122 terabyte QLC, and we are anticipate a new battle of this as Huawei, Kioxia, Micron, Phison, and Samsung, and SanDisk, SK Hynix, and Solidigm announced their offering. And we can easily imagine that it will become the 145 to 256 terabyte when they will be available and their drive density standard for the exascale rack. Okay, next one is about NVIDIA. NVIDIA might speed up a cooling solution with the next-gen Rubin Ultra as it battles the thermal constraints. As NVIDIA GB200 AI Lab, NVIDIA is supposedly planning to switch an entire new cooling solution for the next-gen Rubin Ultra AI lineup, as it tried to mitigate the growing power requirements and thermal concerns. NVIDIA plans to switch to microchannel cover plates with the Rubin Ultra, squeezing out optimal performance per watt level. For those unaware, having an adequate cooling solution for next generation systems is one of the top concerns for firms like NVIDIA, as power draw levels rise tremendously with each iteration necessitating sufficient cooling mechanism on board. According to QQ team, it is believed that NVIDIA is contracting cooling solution partners to integrate direct chip cooling through the microchannel cold plate for its Rubin Ultra AI GPUs, which could prove to a significant shift from conventional liquid cooling solutions and enable NVIDIA to achieve for top-tier performance. An excessive concern over the microchannel cover plate issues growing in Rubin GPU and ASIC demand to boost liquid cooling revenue in 2026. The market previously rumored that cooling Rubin GPU TDP at 2.3 kW might adopt the microchannel cover plate MCL, microchannel cover plate MCL, but recent update right here. The let's discuss the microchannel cover plate MCCP mentioned here, as it is somewhat similar to the direct die cooling, and which could offer clocking and CSD often employed with modern CPUs. And it involves the copper cold plate and the microchannel embedded inside that allows cold content to flow around. This allows the plate to create a local convection, reducing thermal resistance from the die to the fluid, and similar to the NVIDIA's current conventional cooling solutions, exception that changes are made directly to liquid-cooled plates on the chip, enabling significantly more efficient thermal management. I could delve into a more specific about how MCCP works, but it's essential to understand and why NVIDIA requires these technologies in the first place. Team Green is in real tight production cadence and scaling up to the Blackwell 2 Rubin brings and much higher power requirement, especially in complex large-scale systems, which is why it's necessary for NVIDIA to think out of the box even if the company does desire it. Architectural advances force them to invest in advanced cooling solutions. It's claimed that NVIDIA has contracted Asia Vital Component, the Taiwanese thermal solution provider, to design the MCCP for the Rubin Ultra. However, it was initially planned for Rubin for the right timeline has given the suppliers inefficient time to switch to advanced solutions. Interestingly, so the Microsoft recently announced the microfluidic cooling, an approach similar to the MCCP, was the key difference with the focus on chip cooling. In chip cooling, as well, the coolant is located either the inside or the backside of the silicon itself. This demonstrated that the industry definitely needs new cooling options. The next one is about storage. The Kioxia and SanDisk announced beginning to operation of the Fab 2 at the Kitakami plant in Japan to produce 8th generation 218-layer 3D flash memory featuring the company's CBA CMOS directly bonded to array technology and future advanced 3D flash memory nodes. The Kioxia Corporation, a subsidiary Kioxia Holdings Corporation and SanDisk Corporation, announced the start of the operation at the Fab 2 K2, a state-of-the-art semiconductor fabrication facility at the Kitakami plant in the Iwate Prefecture, Japan. Fab 2 has the capability to produce 8th Gen 218-layer 3D flash memory, featuring the company's CBA CMOS directly bonded to array technology and future advanced 3D flash memory nodes to meet growing demand for storage driven by AI. Production capacity at Fab 2 will ramp up in the storage over time in line with the market trend, with meaningful output expected to begin in the first half of 2026. The Fab 2 facilities has an earthquake-absorbing architectural structure and design that utilizes state-of-the-art energy-saving manufacturing equipment. The facilities uses AI for enhanced producing efficiency and employs a space-efficient facility design that enlarges that space available for manufacturing equipment in clean rooms. A portion of investment for Fab 2 is subsidized for the Japan government according to the plan approved in February 2024. We are pleased to start the operation of our Fab 2 facility in Kitakami plant, said Koichiro Shibayama, president of the CEO Kioxia Iwate Corporation, which operates the Kitakami plant. The 8th and further generation 3D flash memory project produced at Fab 2 will offer new value for the rapidly emerging AI market. We will continue to leverage our partnership and the economics of the scale of the production of advanced flash memory product and achieve organic operation growth. Kioxia will continue to contribute to advance of the semiconductor industry and the development of the local domestic economies. So as the AI advances is poised to transform the industries and refine the careers and reshape their daily life in ways we are beginning to imagine. The flash memory is at every center of this transformation, unlocking the speed and efficiency and scalability needed for this next wave of innovation. We are proud of our long-standing partnership with Kioxia, and the scale it provides to enable our customers to fully harness AI opportunities. Added Maltriers Mahajani, SVP, as Flash President, Front and Operations, SanDisk. So the two companies have shared a successful joint venture partnership for over 200 years and will continue to maximize the synergy and competitiveness through the joint development of 3D flash memory and making capital investment according to the market trend. Okay, today thank you for your time. See you next time.